Alright, so our first section, integration by parts. So this is chapter 2 in the N6 syllabus, and it's a continuation from chapter 4, the last part of chapter 4 in N5. Okay, it's called integration by parts. So in N5 you would have done all the other types of integration, and then the last thing that you do is integration by parts. So here's an example of integration by parts. Right, so now, how do you know that you have to use integration by parts here? Let's go back. Let's take an example that looks like integration by parts, but it is not. So in N5, if you remember, well, I call this type A when you have the integral of f of x to the power n times f prime x dx. Alright, so we're going back to our exact derivatives here. You have to know your differentiation in order to do the integration. So, what is happening here? You've got f of x and then multiplied by the exact derivative of f of x, which is f prime x. These two here, k and n, are just numbers. So constants, we call these are just numbers there. Alright, so in a situation like this, okay, so let's take an example. We got the integral of ln x times 1 over x. Okay, now if you compare this example to this one, it looks similar, but the way you integrate it is completely different. Okay, so now let's go back, let's revise this one. It only takes a few minutes. How do we integrate something like this here? So first of all, you need to know your differentiation. You must know it. Do not rely on the formula sheet. You should know that if you differentiate ln x, what is the derivative of ln x? It's going to be 1 over x. So this deals with this type of problem. It can be ln x times 1 over x, or it can be something like maybe sine x to the power 3 times cos x. There's many examples that I can just make up now. The fact is, I have the sine x here, which is f of x, and the derivative of sine x is cos x. So it's an exact derivative. There's two ways to deal with it. One way is just by looking at it by inspection and writing down your answer. Right, and the other way is by using a substitution, which I will advise you to use. So if I want to use a substitution in a situation like this, I will always let u equal to f of x for any example. If it's f of x, f prime x, always let u equal to the original, not the derivative. So in this situation, f of x, remember now, n is just a positive 1 here. There's your n here, there's your 1 there. Can you see that? So now if I let u equal to f, what is f of x in this example? My f of x is ln x here. So now, using a u substitution, if I go du over dx, the derivative of ln x is 1 over x. Now, I can make dx the subject of the formula. So if I cross multiply here, cross multiply, so that will mean I have x times du is equal to 1 times dx. Can you see that? Cross multiply. So now dx is the subject of the formula. So once I have my u and I have dx, then I can substitute here. So I will go here now, substitute. So that's ln x to the power 1 over x. So what am I doing now? I'm going to replace ln x. So there's my ln x. I'm going to replace ln x with u. So there's my u there. And I'm going to replace dx. So I'll replace dx with x times du. So what happens for all these types of examples, exact derivatives? is that when you use your substitution, the variable x will be eliminated from the problem now. So now we're only dealing with the variable u. So this is equal to the integral of u to the power 1 du, because x and x cancel there. Can you see that? So now, when you're integrating, so now it's reduced to the type that you did in n4. So when you got u to the power 1, then 1 plus 1 will give me 2 over 2 plus c, and then you're done. Now, substitute back for u. This is called u-substitution, so that's u squared over 2 plus c. So what is my u? My u is ln x. Okay, so my u is ln x. So now, this is called u-substitution. There is another way by inspection, but I'm not advised. You can do inspection. The problem with inspection is you actually working stuff out in your mind and you're going straight to the answer. So the problem is, what happens if you just write down the wrong answer? So instead of maybe 4 marks, you'll get 0 straight because you just wrote down the final answer, which is wrong. Whereas with u-substitution, at least you can get part marks, even if your final answer is wrong. Okay, so this is one example. How do you know if this answer is correct? So if I take this here, and if I say let's take my answer, let's call it y. What is the answer here? It is 1 over 2 ln x all squared plus c. If I differentiate this, what would I expect to get? If I differentiate my answer, I should get back to the question. That is differentiation and integration. Okay, if I integrate, I get this. If I differentiate, I should get back here. So, let's differentiate this 1 over 2 ln x all squared. What rule do we need to remember from our N5 work? In order to differentiate when we have a power, it's going to be chain rule. If you have a power, it's going to be chain rule. So, if I go dy over dx, so how does the chain rule work? You multiply the coefficient by the power there, so that's going to be 1 over 2 times 2, copy down your ln x, and then what do you do to the power now? You subtract 1 times, now you go inside and you find the derivative of ln x. What is the derivative of ln x? 1 over x. And then obviously plus c, if I differentiate that, that will be 0. So what's going to happen here now? This 2 and this 2 will cancel, so I end up with just ln x, 2 minus 1 is 1 times 1 over x. And was that the original question? Yes. So if you know your differentiation, then you can always check your answer and you cannot go wrong for certain examples where it's easy to check. Certain examples are a bit too long to check, so you're not going to check it. But what you can, you must do. Now, so this is type A. You're supposed to do a full exercise on type A. If you go to the, your exercise in N5, there's many examples like this here which you practice. So then, when you look at an example like this now, if I let u equal to ln x here, let's do the same thing. If I let u equal to ln x, du over dx is 1 over x. So what is dx equal to? X du now. Can you see that? So, what happens if I try and use a u substitution there? I'm going to have my u, I'm going to have my x, and I'm going to have x du there. Right, remember this part here, x du. There's my x du is actually dx. So what do you notice? It does not cancel here. You cannot have two different variables now. It does not cancel. So it's not going to work. This technique does not work here. Can you see that? So now, that's where we use integration by parts. Alright, so how does integration by parts work? We're dealing with multiplication. Same like this one. Here we are dealing with multiplication. We're also dealing with multiplication here, but one factor is not a derivative of the other. So what do you do now? Integration by parts. Let's have a look at the formula here. This is it. This is the question, and this is the formula for the answer. So your question here is f of x times g prime x, and you got two. One is f of x, the other one is g prime x. So now we got ln x and we got x there. Which one is going to be f of x? Which one will be g prime x? There's only two. Now how do you know which one to choose? Okay, so there is your priority list. It's not given to you on the formula sheet, you memorize this priority list. Alright, so we got number 1, 2, 3, 4, 5. So let's compare. Ln x, what is ln x on the priority list? Let's write it down. So ln x, first of all, number 1 is inverse trig functions. Arc sine, arc cos, or inverse sine, inverse cos, inverse tan. Number 2 is your logs. So you can have logs or natural logs, that's ln. Clearly, this is number 2 on the priority list. Can you see that? So this is number 2 on the priority list. And then x, what is x on the priority list? Powers of x here, this is x to the power 1. Can you see that? So this is number 3 on the priority list. Now, this priority list is for choosing f of x. So let's write it down. What is my f of x? So f of x is equal to, now, you got number 2 and number 3. You always will have either number 1, 2, 3 or 5. 1, 2, 3, 4 or 5, I mean. So, whichever one is higher up. Is number 2 higher up or number 3 higher up on this list? Which one is higher? Number 2. So whichever one is higher must be chosen as f of x. That's how we use integration by parts now. So number 2 is higher up on the priority list, so f of x must equal to ln x. So what am I doing now? I'm identifying my f of x. So therefore, the other one will be g prime x. So therefore, g prime x is equal to x. You're clear with that? That's how you use the priority list. There's only 5. The 1, 2, 3, 4, 5. Whichever one is higher up must be chosen as f of x. Now, let's have a look at the formula. So we know that in the formula, this formula is given to you. So, wherever you see f of x, I'm going to replace f of x with ln x. Now, the formula has f of x in it times g of x. Now, this is not g of x, this is g prime x. So we need to still find, we need to work out g of x. What else does the formula have? F prime x. This is not f prime x. F prime x means differentiate f of x. So we need to work that out. Alright, so now we can work it out. So once f of x is ln x, so therefore f prime x, the derivative of ln x will be 1 over x. Now g prime x is equal to x. Now what does g prime x mean? It means you differentiated something and then your answer was equal to x. So I want to know, what did you differentiate in order to get the x? How do we get that original function? We use integration to get back. So g of x, you're going to integrate x, and when you integrate x, it's going to be x squared over 2. Now we have all our information, and now let's write down the formula, and let me do it here. Let's write down the formula and substitute. So this is how you're going to answer now. You start, you're going to write down the integral of ln x times x dx is equal to, you look at the formula sheet, or you try and memorize that if you want to. Copy down the formula, f of x, g of x minus the integral of g of x times f prime x. Alright, so now we do the substitution. F of x, g of x minus the integral of g of x, f prime x dx. So what is my f of x now? My f of x is ln x. And don't be careful, don't go and substitute g prime x. This is g of x. What is g of x that we worked out now? X squared over 2. Remember, g of x is repeated. It appears twice in the same formula. You can see that. So that's going to be x squared over 2. And then f prime x we worked out, which is 1 over x. So after we substitute into the formula, then the focus is now on the integration part. So what you need to do is, you must always simplify first. So now we need to simplify this here. Simplify first and then check how are we going to integrate. Do we still need to use integration by parts, or is it something that we know from N4, N5 straightforward? Let's see. So now this is going to be my ln x times x squared over 2, and here now simplify. It's best to take the constants, which is your fraction is 1 over 2 there. Can you see that? So take your fraction, multiply it by the number in front, which is minus 1, and write it. So it's basically minus half there. Can you see that fraction there? And then I will write down my integration sign with respect to x, and then x squared divided by x is equal to just x to the power 1. So you simplify. Why do you simplify? And now you need to check now. Do I need integration by parts to do this here? No. So this is straightforward. I can go and work it out now. So this will be ln x times x squared over 2 minus 1 over 2. Integrate your x. So that will be x squared over 2. Remember, this is multiplication because it's minus half times your answer. So minus half times x squared over 2. And now all integration is done. Notice I did not put down plus c when I was working out the small part here. Only at the end. After all integration is done, you put plus c one time. So let's just simplify that. So that's going to be ln x times x squared over 2 minus 1 over 4 times x squared plus c. Right, so now before you copy this down, I just want to show you, we're not going to do it all the time, but I'm going to show you that if we take this answer and differentiate it, just like we took the answer here and differentiated it, we got back to the question. So I'm just going to show you that quickly, but there's no time to do it for every single example. And in the N6 exam, there's no time, you have to write very fast here. Why am I showing you this? Because I'm going to be revising the product rule with you at the same time. So at the same time we're revising the N5 work. So let's take the answer. Let's call it y. So let y equal to, what do we have there? We have ln x times x squared over 2 minus 1 over 4 x squared plus c. And if I differentiate my answer, I must get back to the question, which is ln x times x, and if I don't, that means I made a small mistake somewhere. So let's check now. So what is this here? This is multiplication now. Can you see that? So if I need to differentiate multiplication, what rule do I use? I use a product rule. So what do you all call u, v, f, g? What we are calling it for product rule? F and g. Okay, so that means this is f. This is g. So the product rule is going to be f g prime plus g f prime. That is a product rule. So I'm going to go dy over dx. Alright, so the product rule here is copy down the first factor, ln x. Differentiate the second one. In other words, f g prime. So the derivative of x squared over 2. If I bring down the 2 here, 2 and 2 cancel, so the derivative is just x to the power 1. You're clear with that? Right, so that's f g prime plus g. What is g? X squared over 2. And then f prime. What was f? Ln x, so f prime means 1 over x. Product rule is done. Only one more thing to do here. Can you see that? So this is minus 1 over 4. X squared, so I need to differentiate minus 1 over 4 x squared. What is the derivative here going to be? Minus 2 over 4 x. What is minus 2 over 4? It's the same as minus 1 over 2. Alright, you should know that by now. 2 over 4 is the same as 1 over 2. And then plus c, that means plus 0. Now let's check what happens here. So I got ln x times x. What does this simplify to? X squared over 2 times 1 over x. X squared divided by x is just x. Basically x over 2 or 1 over 2x, it means the same thing. Can you all see that? So that's plus 1 over 2x minus 1 over 2x. So therefore, my final answer, these two, 0 here. So therefore the answer is just ln x times x, which was the original question. That means the answer is correct. Can you see that? So that is a way to check, it's a way to practice your N5 differentiation at the same time. Because obviously you are going to be using differentiation, which is part of integration. Alright, so copy this down. I'm going to deal with another one now. Okay, let's have a look at the second example here. This is the second example, integration by parts. Now, first of all, let's go back to our N5 work and look at an example that's similar to this, but it is not integration by parts. So let me write this down. So let's say this is under integration of trigonometric functions in N5. So if I'm integrating, let's say, if I got x squared and sine of maybe 3x cubed dx. Alright, so now if you look at these two examples, they look the same or they look similar. For somebody that's not familiar with this, you might think that, hey, it's the same type of example, I need to do it in one way only. So now, this one, here, the difference is that this is in the form sine f of x multiplied. Notice what is my f of x now? It is this part here, the angle, like sine of 30 degrees, sine of 40 degrees. F of x is the angle and the derivative. It is multiplied by the derivative. The whole sine of f of x is multiplied by f prime x. Okay, so in an example, in a case like this, similar to the one that I've just done before, it deals with different exact derivatives. So, how will I integrate this here? If I have f of x, f prime x situation, always let u equal to f of x. Right, so you always let u equal to f of x. So in this case, f of x is this part here, which is 3x to the power 3. So now if I differentiate here du over dx, what is the derivative of 3x to the power 3? 3 times 3, that will be 9x squared. So I need to make dx the subject of the formula. So therefore, dx is going to equal to du divided by 9x squared. You all follow what happened there? Right, so now I have the integral. I have x squared sine, and now 3x cubed, there's a here, is now replaced with the letter u. So let me replace it here. There's my u. And dx, there's my dx. There's dx here, is replaced with du divided by 9x squared. So that's going to be du divided by 9x squared. Notice what happens now. X squared and x squared will cancel. So I end up with 1 over 9, the integral of sine u du. So now it's reduced to an N4 type problem now. In N4 you are asked to just integrate sine. Okay. So when I integrate sine, what is the answer then? When you integrate sine, it is minus cos of u plus c. So therefore it's going to be minus 1 over 9 cos of u plus c. What was u? What was u here? 3x to the power 3. So that's one type. Now let's take this and differentiate it. Let's revise the N5 work one time. Let's take this example here. So let's take the answer. Y is equal to minus 1 over 9 cos of 3x cubed plus c. Let's go back to chapter 2 in N5 differentiation. Okay. So what is the derivative here? So if I go dy over dx, the derivative of cos is what? Right, so it's best to know your table of derivatives off by heart, otherwise you're going to be too slow. You are too slow, you're going to be looking for the formula sheet now. You're busy looking for where is the derivative of cos, whereas other students are gone, they moved on. You're busy looking at the formula sheet, people are they've moved on to the next question. So what is the derivative of cos? The derivative of cos is minus sine of whatever you have here, your function of x, which is 3x cubed times, what do I do next? I need to differentiate 3x cubed. This is the chain rule also. The derivative of cos is minus sine of 3x cubed times the derivative of 3x cubed. 3 times 3 will be 9x squared. We're done now. Plus the derivative of a constant is 0. Now let's simplify this here. So therefore, a negative times a negative here. Positive, I got 9 in the denominator, 9 in the numerator. It's all multiplication. What will happen here to this two? So what is my final answer going to be? It's going to be sine of 3x cubed times x squared. Was that the question? Yes, it was. Can you see that? So this is an N5 type of example, which can come out in other work that we're going to do. But you must notice the difference. Okay. Now, notice when I'm saying notice the difference. Here you had x squared sine of 3x cubed. So what is it that you have to remember here? Check the angle. If this is an x cubed, the derivative of the x cubed, look at the x only. Forget about the 3 in fraction. We are interested in the x's. Will it cancel? So when I differentiate the x cubed, I know I'm going to be getting an x squared. And I have an x squared here, so I know it will cancel. Can you see that? So you know that this is dealing with exact derivatives. But clearly now, what is this? This is x to the power 1. When I differentiate x to the power 1, will it cancel with x squared? No. So I cannot use the same technique that we used in N5 here. Now this is integration by parts. So we go to our priority list. Priority list, what number is this one here on the priority list? What number is it? Number 1, 2, 3, 4, or 5? This is number 3. What number is this one on the priority list? This is number 5. So, which one do we choose for f of x is, which one is going to be our f of x? The one that's higher up. We start, the highest is number 1, second highest is number 2, third one is number 3. So which is higher up from number 3 and number 5? Obviously, number 3. So therefore, number 3 is going to be f of x. The priority list is only for choosing f of x, nothing else. So that is my x squared. So therefore, g prime x is equal to the other one there, which is sine 3x. Once we got that sorted out, now all we have to do is find f prime x, find g of x. So, if f of x is x squared, f prime x will be 2x. G prime x, that means when we differentiated something and the answer was sine 3x, now we need to integrate sine 3x, and I just gave you the formula for integrating sine there. There's it here. When we integrate, let me write it down properly for you now. So when we're integrating sine of bx, not bx squared, or it's just sine of bx, like sine of 2x, sine of 3x, the formula, going back to n4 now, is going to be minus cos bx all over b plus c. That is the formula for integrating sine. So when I integrate sine, I'm going to get minus cos 3x all over 3. We do not put down plus c because this is not the final answer. We're still going to substitute into our formula. Now, so we're going to go the integral of x squared sine 3x dx. We copy down the integration by parts formula, which is f of x g of x minus the integral of g of x f prime x dx. And now we do our substitution, and then we're going to simply, let me give you 2 minutes to just do the substitution and the simplification. Alright, so we do the substitution now. So f of x, f of x there, which is x squared, then g of x is minus cos 3x over 3. Remember, g of x appears twice in the formula, so therefore this is minus cos 3x over 3, and then f prime x is what we worked out there, which is 2x. Now, if I remove the brackets, that's minus x squared cos 3x over 3 there. Here, a negative times a negative is positive. My fraction here is 2 numerator, 3 in the denominator there. Can you see that? So that will be plus 2 over 3, the integral of cos 3x times x dx. So that's what I mean by simplify. Take the constants, write it in front here so you can see clearly now what do we need to do in order to integrate here. Is it an n5 type? Can I let u equal to 3x? Will the derivative of 3x cancel with x? No. If it does not cancel, that means it's not exact derivative. That means we need to use integration by parts. So forget about everything that just happened here now. The focus is on this point here now. So we need to use integration by parts to work this out. So therefore, let's write down our new f of x now. So now, what is my f of x? You know, I don't have to write down the priority list again. You know you got x and you got cos. So which one is going to be f of x from x and cos? It's going to be x because x is number 3 and cos is number 5. Whichever one is higher up must be f of x. So f of x is x. So therefore, g prime x is equal to cos 3x. So once I got my f of x, g prime x, then this side I will differentiate, this one integrates. So f prime x, the derivative of x is just 1, and then here my g of x now, I need to integrate cos 3x, and when I integrate cos 3x, what do I get? When I integrate cos 3x is positive sine 3x all over 3. When you integrate cos, it's a positive sign. Okay, when you differentiate cos, then you'll get a negative sign. Be careful of that. So now I'm ready to continue here. So let's write that down. So therefore now I'm copying all this down here. So that's minus x squared over 3 cos 3x, so that's this part here, plus 2 over 3 times, now this is the part where I have to apply the formula now. Can you see that? This is the integral of cos 3x times x dx, open brackets, and apply the formula. This is integration by parts. So that's f of x, g of x minus the integral of g of x times f prime x dx. Alright. And that's going to be minus x squared over 3 cos 3x plus 2 over 3. And now do the substitution. So what is my new f of x now? My new f of x? My new f of x there is x. What is my new g of x? Sine 3x over 3. And then g of x again, which is sine 3x over 3. And then f prime x is 1. Right, so now let's remove these brackets. So that's going to be minus x squared over 3 cos 3x. So if I multiply now, so that's going to be plus 2 over 3 times 1 over 3 is going to be 2 over 9x sine 3x. And 2 over 3 times minus 1 over 3 again is minus 2 over 9. The integral of sine 3x dx. I remove the brackets. Every time I remove the brackets, focus on the integration part. Do I need to use integration by parts again here? No, this is straightforward. There's the formula to integrate it. You can see that. So that's going to be minus x squared over 3 cos 3x plus 2 over 9x sine 3x minus 2 over 9 times, I need to integrate sine. When I integrate sine, it will be minus cos 3x all over 3. And I'm done now. Let me just simplify this last part here. So that's going to be minus x squared over 3 cos 3x plus 2 over 9x sine 3x. A negative times a negative is positive. 2 over 9 times 3 is 27 cos 3x plus c. There's nothing more to do. This is my final answer. Alright, so now an alternate method, but it does not work for all the examples. It will work for an integration by parts example if f of x is number 3, like in this case here. The other example, f of x was not number 3, it was number 2, which was ln x. Alright, so now if we go back, we are integrating x squared times sine 3x. Alright, so that is what we are integrating there. So f of x is x to the power 2. How many times did you use the formula here? You used it 2 times. So if f of x is number 3, I'm talking about x to the power n, then the exponent tells you how many times to use the formula. So if my exponent is 2, I'm using the formula 2 times. You can see that. If my exponent is 3, I'll be using it 3 times. If it's 4, 4 times. That's how it works for an example where f of x is x to the power n. Now, there is a shorter method only for this type of example, not for all the others now. So watch what's happening here. Okay, we know that the formula is f of x, g of x, but what sign is here? The one that you cannot see. Positive. And what sign do we have here now? Minus the integral of g of x times f prime x dx. So we got a positive, we got a negative. Then when we use the formula again, we got another positive f of x, g of x minus g of x f prime x. So you might wonder, why am I talking about the sign? So watch what's going to happen here. Now, this is my f of x, this is my g prime x. So my f of x, I'm going to differentiate, I'm going to leave a space. So in your book, you leave a line here. And then in the next line, you're going to write down the derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 2 is 0. Alright. So only x to the power a positive number can be differentiated down to 0. Now, this was my g prime x. So what do we do with g prime x? We integrate it to get g of x. So watch here. I'm going to integrate sine. I wrote down the formula. There's it there. Integrate sine. I'm going to get minus cos 3x over 3. Then I'm going to integrate minus cos 3x over 3. I'm going to integrate until I come in line with the 0. Then I'm going to stop. Watch now. When I'm going to integrate minus cos 3x over 3, it's going to be minus sine 3x all over 3 times this 3 here, which will be 9. Alright. Now, last one here. I need to integrate sine, so that's going to be, when I integrate sine, it's going to be a minus cos. Alright, so the minus that's already here, and the minus that you're going to get from integration will give you a, now clear with that? That's going to be cos 3x all over what? Over 27. Okay. Now the multiplication comes about. F of x times g of x. What's the sign here? Positive. So in that line that you left, you're going to put a plus, minus, plus. It's always plus, minus, plus, minus, plus, minus, plus. Starts with always a plus. Now watch. This could have been done in a few seconds. It's just that I'm explaining it to you. That's why it's taking a bit long. You multiply diagonally down there, here, here. So what am I going to do? I'm going to multiply that times that, that times that, that times that. Can you see that? Watch now how this happens here. So I'm going to multiply x squared times minus cos 3x over 3. What's the next one then? Minus, I got my 2x times minus sine 3x all over 9. There's a minus. The next one is plus, what do I have there? 2 times cos 3x all over 27 plus c. I'm done now. Let's just simplify this fraction. So this is going to be minus x squared cos of 3x all over 3 here plus 2x sine 3x over 9 and then plus 2 cos 3x all over 27 plus c. Is that the same answer that we got last time? Yes, it is. You can check. You must get the same answer. So this is the table method. It works only if you get an example where f of x is number 3. Our next example. Now, go to your priority list. We have e to the power 3x. So x is the exponent. This is an exponential function. Okay. It's e to the power 3x, exponential graph. And we have cos, which is your trigonometric function. Okay. So what number is e to the power 3x? It's number 4. And what number is cos of half x? number 5. So now, for this one, I want you to write down your working out on the side here. Okay. There's a special reason for this, because this one, I don't want it to get messed up as you're writing there. So, you're going to be using the formula 2 times. You will see why only 2 times. This is a special case example. So, you can write that down. When you are integrating number 4 times number 5 on the priority list, this is number 4, exponential, times number 5, which is a trig function, then it is a special case. You can make your notes there. When you are integrating an exponential times a trig, in other words, number 4 times number 5 from your priority list, it is a special case, and we are going to apply the formula twice only. Because you will notice after you apply the formula twice, you want to apply it again and again and again, and it just carries on and on and on. Okay, so you will apply the formula twice only. So now, f of x is equal to, you know now, which one is f of x? Which one is higher up, number 4 or number 5? Number 4. So my f of x is e to the power 3x. So therefore, g prime x is equal to cos of half x. Alright, so now we need to differentiate this one. So when you differentiate e to the power 3x, the derivative here is e to the power 3x times the derivative of 3x, which is 3. You're clear with that? Then you need to integrate this one here. So you integrate, so g of x will be the integral of cos of half x. So when you integrate cos of half x, we've done this one here also, it's going to be a positive sine half x all divided by half, which is equal to 2 sine half x. Now, let's apply the formula. Now, when you are writing this down, you start, a special case, you make sure the question must be here on the left hand side. You start with the question like this here. You're going to go the integral of e to the power 3x cos of half x dx. So it's a question and then the formula now in this order here. Don't write one below the other like what we were doing there. You write question on the left, answer on the right hand side. So this is going to be f of x, g of x minus the integral of g of x f prime x dx. And now you've got all the information. Let's substitute it. So what is my f of x? My f of x is e to the power 3x. G of x is 2 sine of half x. So my g of x again is 2 sine half x. And then f prime x is what we just worked out now, which is 3 times e to the power 3x. You can simplify if you want to. Let's just simply, that's going to be 2 e to the power 3x times sine half x. Let's remove these constants here. So that's a 2 multiplied by a 3. So that will be 6 times the integral of sine half x times e to the power 3x dx. What do you notice now? Look at the integration. It's number 5, number 4 again. So we need to use integration by parts again now for the second time. Okay, so for the second time, we're going to write down now my f of x. What is my f of x? Same thing now. F of x is still number 4. It is still e to the power 3x. So g prime x is sine of half x. So now what do I need to do? I need to differentiate here. I need to integrate here. So f prime x is equal to, and then g of x is equal to, you know what to do. Let me give you 2 minutes to do this part. Write down the formula, make sure your brackets and everything are 100%. Do the substitution and then wait for me after that. Let me give you a chance to just do this part here quickly. Alright, so let's resume. So we got our f of x, which is e to the power 3x. F prime x means differentiate e to the power 3x, which is going to be e to the power 3x times the derivative of 3x, which is 3. So basically this becomes 3 e to the power 3x. Here you integrate sine, so it's going to become minus cos half x all divided by half. Remember, when you integrate sine, it's minus cos, but when you differentiate sine, it's positive cos. There's a difference here. So now remember, you can't leave it like this here. You are dividing by half, swap, invert and multiply there, so that becomes minus 2 cos half x. So now it is ready for substitution. Now watch how I'm going to introduce my brackets here. Right, so I got minus 6. How do you read this? This means minus 6 multiplied by my integration here. We are multiplying minus 6 multiplied by the integral of sine of whatever this is. Right. So therefore I got my minus 6 times open bracket now. Can you see that? You open your bracket there, and now you will apply the formula for the second time. F of x, g of x minus the integral of g of x, f prime x dx. And now let's do the substitution and see what happens after that. Right, so our substitution, second time we're using the formula. F of x is, what is my f of x? My f of x is e to the power 3x. My g of x is minus 2 cos of half x. So remember, g of x appears twice. So this is going to be minus 2 cos half x. And then f prime x, the derivative there was 3 e to the power 3x. Now remove the brackets. So 2e to the power 3x times sine of half x. Be careful with removing brackets. Now you must understand that we have got only 2 terms here. So it's that multiplied by minus 6, and then this whole thing here multiplied by negative 6. But be careful, there's here, first term, negative times negative there. You can see that? So that will be a positive 12 e to the power 3x times cos of half x. And now we got a negative. Remember, what you're supposed to do is negative times negative first. Work this one out, which is positive. And now removing the brackets times negative, which will give you a negative. In other words, 3 negatives here. A negative times a negative times a negative will be negative straight. Okay. The integral of e to the power, sorry, I forgot to multiply there. I'm only talking about the signs, that is negative times negative times negative is negative. So we got 6 times 2, which is 12 times 3, which is 36. And then we got e to the power 3x times cos of half x. It's multiplication, it doesn't matter which one you write down first. It's either you put in cos times e or e times cos, it's multiplication. Now we applied the formula twice. Now you take this into the question. Remember I told you how to write it down, and you copy it down right here now. So you can use an arrow, so you don't have to copy it down every time. That's the integral of e to the power 3x cos of half x dx. And now, what do you notice? Look at this part here. After applying the formula twice, we're back to the question now. The integral of e to the power 3x cos of half x dx is the same thing. Can you see that? The only difference is here you got a positive 1 and here you have a minus 36. So these are called like terms now. Like terms. So like terms, so it's like I have a is equal to 2 minus 36a. What do you do when you have like terms? You take them all to one side. It's the same thing. It's just that I don't have a. I have, this is like my a now. Can you see that? So what do? I'll take this to the left hand side. So I'll go a plus 36a is equal to 2 or whatever the rest is there. So a plus 36a is 37a is equal to 2. So a is equal to 2 over 37. That's exactly the method that I'm going to be using here. Right, so what I'm going to do now is I'm going to take this. If you want to, you can say let this equal to a, but it's just extra work. You don't want to do extra work. You can say this is long. Just take this whole thing to the left hand side. So we got the integral of e to the power 3x cos of half x dx. Take this to the left, it becomes plus 36, the integral of e to the power 3x cos of half x dx, and we have only these two terms left on the right hand side, which is 2 e to the power 3x sine of half x plus 12 e to the power 3x cos of half x. And now I can add up my like term just like how I added up a plus 36a. It's the same thing. 1 plus 36 will give me 37 times the integral of e to the power 3x cos half x dx. And now it's just copying down. We worked out everything now. It's just to get to our final answer. So that will be 2 e to the power 3x sine of half x plus 12 e to the power 3x cos of half x. What must I do now? After I got the 37a, I need to make a the subject. Same like how I need to make the question the subject of the formula. So therefore, the integral of e to the power 3x cos of half x dx is equal to this whole thing here, 2 e to the power 3x sine half x plus 12 e to the power 3x cos of half x, all divided by 37. Alright, so this is the special case example. Right, you can, I've got this video, so you can re-watch it. Don't forget to subscribe to my channel, okay? And click on like. Because at the moment I got about 720 subscribers. So that means I can upload, I record this like how I'm recording now, and then I'll upload it so you can watch. Once I hit 1,000 subscribers on YouTube, then I can teach live. I can just give you a notification and I can be live in the classroom here, and whoever's sitting anywhere in the world can go. As long as you log on to YouTube, you can watch me live. You see, that's my aim at the moment. to hit 1,000 subscribers. So tell all your friends from all the other colleges. I don't think anyone else is doing what I'm doing at the moment. Tell them to subscribe to my channel. Alright.